I started with a simple top-down game with movement and collision detection, so you can't walk through walls. Then I added the ability to throw water balloons around. They burst when they reach their destination or when they hit a wall. I had to write collision detection routines for different shapes. This all worked well, but it got a little more complicated when I decided to add enemies. First, I used the Poisson disk sampling algorithm to place random waypoints on the map. The algorithm makes sure they're still spaced out even though they're random. Next, I added connections between each point and any points that are within a certain distance of it. Up to this point, I was ignoring the actual map, so some points and connections were inside the walls. I wrote a function that finds these points and connections and removes them. What's left is a waypoint mesh for the enemies to walk on. This will tell them where they're allowed to go when they need to move around. But in a shooter game like this, taking the shortest path to get somewhere isn't always the best option. You always want to stay behind walls as much as you can. But how do you teach the computer to do that? To start, I calculated the line of sight for all the points. Basically, each waypoint knows which other waypoints it could see. I did this by drawing a straight line between each point. If that line intersected with a wall, then there was no line of sight between these points. You can see the line of sight here as I move around. Red points are in my line of sight and blue points are not. Once I knew the line of sight for all the points, I wanted to figure out how well covered that point is from each other point. This is important because even if a point is not directly in your line of sight, it's still not very good cover for an enemy if you can just easily move to the side a bit and see it. To calculate this cover value, I looked at the line of sight for the point itself as well as the other points that were close by. I applied a weighted average to determine a vision rating. This number is a percentage that tells me how well a point is visible. But I wanted the opposite of that, so subtracting that score from 1 gave me my cover rating, which is exactly what I needed. The cover rating is demonstrated here. Red points are well covered, and I am not able to see them at all. They have a cover rating of 1. Green points are fully visible to me and not near any cover. They have a cover rating of 0. Some points where the red and green meet have a color somewhere between the two. This shows points that are right on the edge of good and bad cover. These points are good places to shoot from because it means the target can easily be seen from behind them, but they're still covered nearby. All of these values are saved in lookup tables, so they only have to be calculated once when the program starts. This will make it much faster for the enemies to find their way around. This is all I've finished so far. The next goal is to make enemies use this information to move around the map without putting themselves in too much danger from the player. Thanks for watching.